All right, so here's problem number 10. This is one of the things I was going to show you about yesterday or tomorrow with using the exponent laws to help you rewrite. First off, when we look at this problem, we see that we have 0.5 being raised to a power, and we usually think about that the decay factor is a half, it's 0.5. On this case, it's not because of the way our exponent is for our time. If on an exponential growth or decay problem, if we had y equals a times 0.5 to the t power, we would say that our decay factor is 1/2 or 0.5. But that's when it's just plain old t up there. We have t over 13. So what we need to think about is how I can rewrite that with the exponent laws. We could rewrite this as y is equal to a times 0.5 to the t times 1/13, because t over 13 is really t times 1/13. Then if I'm multiplying in the exponent location, then that means I could rewrite this as a power to a power. So it's 0.5 to the 1/13, and that's being raised to the t power. And so what they want you to do here is they want you to kind of go through that little manipulation. And then I can say this is really a times 0.5 to the 1/13th power. Well, that we can do that on the calculator. We can, and that's what they want us to do. It's also taking the 13th root of 0.5 and raising it to the t. So I would say take 0.5 and then press the little caret button and do it to the 1 divided by 13th power. And whatever that decimal is, that is our decay factor. And that's our decay factor per hour. Because the way the problem is originally set up is saying when we're dividing it by the 13th, it's telling us that every it takes us in order every hour it's really every 13 hours is really a full hour. So we have to go through and if we had t is equal to 13 in the original problem, then that's finally when it breaks down in half. It takes 13 full hours for it to break down in half. And so in this case, what it is to do per hour, well, that's kind of rewriting it. So raise 0.5 to the 1/13th power, and that'll be what your factor is.